Hello everybody, I'm Clareece Nevill and I work as part of the Complex Review Support Unit based at the University of Leicester in the UK. Today I'll be sharing my work around developing a novel multifaceted graphical visualization for treatment ranking within an interactive network meta-analysis web application. So treatment ranking within network meta-analysis is a really powerful tool, but the results can often be misinterpreted or used or presented inappropriately. As a consequence, we as a team wanted to improve the ranking output within our NMA web app, MetaInsight. Therefore, we had two aims. One, ascertain the current methods and visualizations for treatment ranking within NMA, and two, develop a novel graphical visualization for MetaInsight. To make sure we're all starting at the same place, I'm going to quickly introduce NMAs. So firstly, the standard method for gathering evidence systematically whilst also appraising and synthesizing the evidence is called a systematic review. To then obtain a quantitative pooled estimate of the outcome of interest in your review, one can run a meta-analysis to quantitatively compare healthcare interventions or treatments. The next step is to simultaneously compare multiple treatments, which can be done with a network meta-analysis. This is done by forming a network of studies and treatments, and then the NMA uses both direct and indirect information to estimate relative treatment effects. And it is through NMAs that treatments can then be ranked. Our first step was conducting a targeted review of the literature since January 2011, looking at papers that introduced, discussed, or compared ranking methodologies or visualizations. This gave us in total 29 academic papers and articles. Within that 29, there were two articles that were particularly useful. As part of their paper, Veroniki and others authors produced a wonderfully concise summary of common ranking statistics and their primary characteristics. The paper by Kosmeyer and authors is a brilliant detailed record of graphical visualizations currently used within the field of evidence synthesis. So from these articles, what did we learn about treatment ranking statistics, and which ones are important? I'm going to bring forward 4 key points I found. So firstly, most ranking statistics are based on Bayesian methods, where multiple simulations are run, then giving rank probabilities based on the rank distribution outputted from these simulations. Secondly, a popular option that appeared was the surface under the cumulative ranking curve, aka the SUCRA, and this does what it says on the tin. It gives a single value but incorporates the entire ranking distribution, but naturally still has limitations. There does exist a frequentist alternative, the p-score. However, some authors have indicated that its interpretation can be challenging. While simpler methods may be easier to understand, such as probability best, they are often more unstable and don't encompass the entire analysis. The opposite is also true, i.e., whilst more complex methods are more rigorous, they can be harder to understand. And finally, interpreting ranking in isolation is not advised. There are many things to consider alongside ranking results, and not doing so can lead to exaggeration of results or misunderstanding. The literature also introduced us to lots of visualizations. There are too many to mention in this presentation, so I'll focus on those that I felt worked well and fitted within the remit of a single outcome, as this is what MetaInsight works with. So first we have rank-grams, which are a popular choice with lots of variations, and they essentially plot all ranking probabilities for all treatment and rank combinations. They can present the results on the same or separate axes, can use lines or bars, and can present absolute or cumulative probabilities. Cumulative rank-grams are also known as SUCRA plots due to their direct relation to the SUCRA statistic by definition. Generally, rank-grams were found to provide informative, balanced summaries of the distribution of ranks. However, some people have stated that comparing treatments can become difficult. An alternative that is less commonly used is a radial plot. Generally, radial plots have an outcome measure, for example SUCRA, marked radially around a circle. Some variations use a donut shape and use coloured-coded sections to indicate the value. The benefits of this layout include the ability to present concentric circles to consider multiple outcomes or subgroups, and including other information nested in the middle, such as a network plot. However, a limitation of working on the radial scale is that generally humans struggle to discriminate between radii lengths. Next, the ability to display multiple elements of an analysis in the same space, a multifaceted display, allows researchers to present the larger picture. And this is great for treatment ranking, as it allows users to form robust and sensible inferences by drawing conclusions from a combination of sources. However, one does need to be careful to not overload the reader with large amounts of information. And finally, with advances in technology, a natural movement in the field of data viz is incorporating interactivity. Interactivity allows users to drill down further into the data or analysis as they wish, and can even involve users choosing their own settings. For example, this interactive visualization allows users to specify the relative importance of outcomes regarding treatment choices. So that was just a snippet of the literature that we found, and it provided great direction and knowledge when developing our own graphical tools for treatment ranking within MetaInsight. So 3 things to quickly mention regarding how we develop these tools. 1, we decided to start with just Bayesian analyses due to its popularity in the treatment ranking field. 2, designing the tools was very much an iterative process of creating designs, sharing them, getting feedback and going back to the designs, starting with pencil and paper and moving on to mock-ups with different software. And thirdly, the final designs were created in R, which is what MetaInsight runs on, and the ggplot 2 package. Now, before sharing what we came up with, let me quickly introduce the exemplar dataset for this presentation. This is the inbuilt example dataset in MetaInsight for continuous outcomes. It compares pharmacological interventions for the treatment of obesity. The outcome of interest is BMI loss 3 months from baseline, and the NMA was on 24 studies, including 5 treatments plus a placebo. So our first plot we're presenting, we've called the Litmus Rank-O-Gram. The base is a rank-O-gram, which we've chose due to its popularity and easy to understand nature. To aid interpretation, we decided to plot cumulative probabilities and have all curves on the same axes. And with cumulative probabilities, one can then say that the nearer the curve to the top left corner, the better the treatment. It was reported that comparing curves can be difficult, so to further aid comparison, we added a litmus strip of SUCRA values, which has 2 functions. 1, to act as a key through the colours, and 2, gives the SUCRA, which is easier to compare. So for this example, one can see that the ranking analysis indicates that rimonabant performs well, as we can see the green colouring, high SUCRA value, and the probability curve being near the top left. For the converse reasons, placebo performed worse. And you can see that it's hard to discern between the 2 curves for metformin and orlistat subatramin, which may seem like a limitation. However, I believe it actually emphasises the point that they performed equally well. And next we have the Radial SUCRA plot. We decided to develop a second plot for 2 reasons. 1, as the number of treatments increase, a rank-O-Gram like the one I showed earlier can easily become crowded. And 2, we really liked the radial plot with the nested network plot that I showed earlier. And so we created this at the price of losing some of the granularity that the Litmus Rank-O-Gram gives. So for each treatment, its respective SUCRA value is plotted radially in descending order. We stuck with the SUCRA to not overload users with various statistics, and the SUCRA considers the entire ranking distribution whilst outputting a single value. To keep things consistent between the plots, the same colour scale was used, with the colour of the nodes also indicating the SUCRA value. We are aware that SUCRA is now represented in 2 manners and thus could be seen as wasted ink. However, we believe it further aids communication and impact. So we took the plot by Sider et al. And took it a step further by overlaying the network plot rather than nesting it. Therefore, the size of the nodes represent the number of participants in each treatment arm, and the thickness and presence of connecting lines indicate the number of trials that directly compared the respective treatments. And we felt that overlaying the network plot meant less work for the users and more impact. The benefit of including the network plot in this way is easiest to see if I unpack this example. So one can see that rimonabant performed the best, due to its high SUCRA and green colour. However, it's actually quite hard to see rimonabant due to its small node size from having few participants in the treatment arms. Furthermore, one can see that it isn't very well connected to the network. These immediate factors should tell the reader that the result from rimonabant should be interpreted with caution. On the other end of the scale, the large red node for placebo immediately shows that there is a good amount of evidence supporting that placebo did not perform well against the other treatments, and that we can be fairly confident with that result. It has been noted that having the network plot overlaid like this could become messy and hard to read for large amounts of treatments or connections. So in such cases, we created an alternative version of the plot, which goes back to the original nested layout. However, we've kept the nodes coloured according to their sucra value. As I mentioned earlier, a key message that is present in the literature is that we should avoid presenting ranking results in isolation. In this spirit, the final ranking graphic tool was designed to be a ranking panel. So here's the design. The central pane contains the ranking plots that I've just presented, as these are the focus, the headline act. Then on the left, we present the relative treatment effects. This will aid interpretation of the ranking and reduce potential exaggeration, as an inherent risk of ranking is accidentally putting undue emphasis on treatments performing differently purely due to being ranking differently. Then the aim of the right pane is to give users the opportunity to explore and interrogate the data behind the ranking analyses. Currently, this is just a network plot, but we have other plans that I'll mention later. Finally, here is a video illustrating how the ranking panel looks and performs within MetaInsight, our NMA app created with R and the Shiny package. Firstly, we run our Bayesian analysis and then click on tab 3C to access the ranking panel, and this is how the panel initially looks. The user can switch between the two new ranking plots as they wish, including the simplified Radial SUCRA plot, and there is also an option to have the plot in a colour-blind friendly colour scale. All of the plots can be downloaded and the ranking results exported as a CSV file. Furthermore, as is the case throughout MetaInsight, there is functionality to run a sensitivity analysis where you can remove studies and compare the results. So this new treatment ranking panel is currently live in a beta version of MetaInsight, so please do have a look and play around. We do have future plans and ideas, including the ones that I alluded to earlier in this talk. So firstly, there are plans to extend the contents of the left and right panes within the ranking panel. Regarding the left pane, we plan to allow the reader to switch between relative and absolute effects. With the right pane, we very much intend to increase the number of visualisations available to the user. Current plans include incorporating some form of risk of bias or grade visualisation, so users can see the quality of the studies being analysed. We also anticipate including David Philippo's bias interval plot, where users can ascertain what level of bias could change the results and thus how robust they are. We have lots of ideas for making the panel more interactive, including options to easily change the reference treatment where applicable. We plan to look into using the Plotly package to enable further information via hovering. Unfortunately, it isn't simple to just quickly convert ggplot objects to Plotly objects for these plots, as they have multiple layers. And finally, we plan to wrap the newly developed plots into an R package so that other researchers can create them with their own data but outside of MetaInsight. So thank you for your time today. I just want to acknowledge Will Stahl-Timmins, the Biostatistics Research Group at the University of Leicester, and the rest of the CRSU group for their input into developing these designs. And you can have the link again to the app so you can explore it yourself. Thank you.